including these new fractions. It was time for the Egyptians to apply their knowledge to understanding shapes that they encountered day to day. These shapes were rarely regular squares or rectangles, and in the Rhine papyrus we find the area of a more organic form, the circle.
What is astounding in the calculation of the area of a circle is its exactness, really. How they would have found their method is open to speculation, because the texts we have do not show us the methods how they were found.
This calculation is particularly striking because it depends on seeing how the shape of the circle can be approximated by shapes that the Egyptians already understood. The Rhine papyrus states that a circular field with a diameter of 9 units is close in area to a square with sides of 8. But how would this relationship have been discovered? My favourite theory sees the answer in the ancient game of Mancala. Mancala boards were found carved on the roofs of temples. Each player starts with an equal number of stones, and the object of the game is to move them around the board, capturing your opponent's counters on the way. As the players sat around waiting to make their next move, perhaps one of them realised that sometimes the balls fill the circular holes of the Mancala board in a rather nice way. He might have gone on to experiment with trying to make larger circles. Perhaps he noticed that 64 stones, the square of 8, can be used to make a circle with diameter 9 stones. By rearranging the stones, the circle has been approximated by a square. And because the area of a circle is pi times the radius squared, the Egyptian calculation gives us the first accurate value for pi. The area of the circle is 64. Divide this by the radius squared, in this case 4.5 squared, and you get a value for pi. So 64 divided by 4.5 squared is 3.16, just a little under 2/100ths away from its true value. But the really brilliant thing is the Egyptians are using these smaller shapes to capture the larger shape.